right? Now, previous class we have completed about different types of forces. In that, normal force, somebody asked me about normal force. Normal force is what? If any object lies over there, so that object, definitely it will have gravitational force which is acting downwards and exactly perpendicular to the object. So normal to that, some force will be acting, that we call it as a normal force or normal reaction force. It can be denoted with N or R. Okay, both the notations I am showing here. So not only in this plane surface, if it is if it is at if it is at a inclined surface also. So anyhow, the weight of the object, gravitational force acts exactly downwards, but normal force acts always perpendicular to the object which we are considering. Right? So that is about normal force concept which we have completed in the last class. Now what we are going with? We are going with the concurrent forces. Right? In concurrent forces means, just now somebody told me, what is that? Acting at the same point, right? So if number of forces acting on some object at the same point, then they are said to be concurrent forces, right? So now suppose if these two forces only, if we take example, okay, at this point these two forces are acting, these two forces can be taken as concurrent forces, right? Now, so generally we won't consider this example. Now, I will show you how exactly these concurrent forces will be taken. Oh, let me erase this, then I'll continue with the concurrent forces example. Now, suppose, let me take with a free body diagram, some forces like this is one force example, and this is other force example, and this is one more force example, right? Now, so if these three forces are acting, those three forces are taken as concurrent forces, right? So all those are acting. See here, I am not writing coordinate axis here. Don't think that this is coordinate axis. Better I will change it. This, any one of the force I'll change. Wait a minute, I'll come back again. This and this and this. So some forces are acting at the same point. Now, so these forces, suppose if we write this as F1, this is F1, and this is F2, and this is F2. So these three forces are acting at the same point. Such three forces can be taken as concurrent forces. So why we are dealing with this is, if number of forces acts, what will be the resultant? That has to be known. Further, we are going with it. Okay? Now, if any body, if it is in under concurrent forces, means if it is under action of concurrent forces, and we are considering that body is said to be in equilibrium when there is no change in the state of its rest. Suppose if the body is here and if it is not changing its position, even though there are some concurrent forces are acting, then the body is said to be in equilibrium. Okay. Now, so what we are going to deal with here, we are going to deal with equilibrium. Equilibrium means what? In generally in the lower classes also you might have studied. Equilibrium means the net force acting on some object. If it is zero, then we take it as the object is at rest. So here the concurrent forces, when they are acting, if the object is not changing its state of rest, then those condition of that object is said to be equilibrium. Now, in equilibrium, so what we are saying, net forces, whatever may be the number of forces, the net forces we will take it as zero. That means F net is equals to zero. Summation of F net is equals to zero. That means we have to add up all the forces. So here I will take dimensions also into consideration. That means if summation of F net is equals to zero, means summation of Fx Fx is also equal to 0. Summation of Fy is also equal to 0. Right? Now, summation of Fz is also equal to 0. That means along all the directions also it is the net force will be equal to 0, right? So that is what, how do we separate individually, like resolution, if we go with, okay. Now, as force is a vector quantity, we have to represent with that, okay. So along each dimension we have a written, okay. Now here also better we can mention this in terms of vector notation, right? Now here I will go with one small theorem, Lami's theorem will be there, so that I will cover here. So, like if these three forces are there, if these three forces are there, those three forces can be represented with a triangle also. Like this, see, this force is there that I will write as it is. This force, first one, whatever I am showing here, that only I have written. Whatever randomly, arbitrarily example I have taken, this is one force, okay. Now let me write that direction afterwards. And the second force is this, no. So this I am writing, okay, as it is I have written. This is there, no. This I am taking a parallel vector. Vectors, when we are representing, we can represent with one parallel vector also, right? This is other vector, right? Third one. No. Here, what is happening? Three forces we have taken. The given three forces, the given forces, if they are number in three, so we can take with the sides of a triangle. Okay. So concurrent forces can be taken as three sides of triangle when they are given three in number, right? So because why I am saying this is important when I said we will have one. Practical related to concurrent forces, there we will be using this triangle of forces. Okay? When concurrent forces are there, we will be using this. That's the reason I am explaining this concept also. When concurrent forces are there, if there are three, the three can be represented as three sides of a triangle, right? And based on this, one more we have Lami's theorem. Lami's theorem. So Lami's theorem explains about what means if there are concurrent forces, if the object is in equilibrium, then what do we write is, let me write a diagram for this, then I will write expression of it. Just hold on. Right, I will stop. I will give a break to this. Then right. Now, so to separate, I have done it. Let me draw diagram of it. Then I will go with the explanation part. So three forces I am considering. This is one force, okay, and this is other force. Okay, that's here. Next, third force is acting over here. Suppose, okay, three forces. For these three forces, I am applying. I am trying to apply this whatever concurrent forces concept I am using with the help of Lami's theorem. So three forces are there. F1, this is F1, and this is F2, okay, and this is F3, right? Now, in these three forces, so the angle between these three forces also I am considering. So angle between them, so angle between F2 and F3, angle between F2 and F3 I am taking it as alpha, F2 and F3 and F1 I am taking it as beta, okay, and this I am taking it as gamma, okay. Three angles also I mentioned. Now, that means F1 opposite angle is alpha, F2 opposite angle is beta, F3 opposite angle is gamma. I am considering, right? Now, make sure that you just remember in such a way only. We are considering in that way also. Okay, F1 opposite angle is alpha, right? In that way we will take here. And what Lami's theorem gives us, it gives one relation to us. That relation we will follow when we are using this in concurrent forces experiment, or when we are solving the problems related to concurrent forces. So the relation given by Lamy is F1 by what is the opposite angle of F1? Alpha. We will take the sine of alpha. F1 by sine of alpha is equals to F2 by sine of beta is equals to F3 by sine of gamma we will take. Okay. So this gives Lamy's theorem, right? So Lamy's theorem expression is what? F1 by sine alpha is equals to F2 by sine beta is equals to F3 by sine gamma, right? So this is Lami's theorem. With this complete concurrent forces concept is completed, right? We will use this concurrent forces in case of one experiment as well as in case of problems also. It is important, right? Uh, with this Newton's second law topic almost completed, we will go with Newton's third law, right? So what does Newton's third law says about the well-known thing in school level also? So to every action there is always an equal and opposite reaction will be there, an equal in magnitude and opposite in direction, right? So to every action there is equal and opposite reaction will be there when a body exerts force on any other body. So what happens? The other body also exert force on the primary one, right? So in nature, everywhere force does not exist alone. Definitely force exists in pairs only. So that is what Newton's third law explains us. Okay. So we have seen we know many examples for Newton's third law. We'll come with those examples also, right? So what is the statement of this? To every action. Let me write statement, then I'll continue with the different examples. To every action, there is an equal. Equal means what? In magnitude. Equal and opposite. Opposite means what? In direction. Opposite in direction. Right? Equal and opposite force or opposite reaction exists. Right? So if our primary force is action, then the secondary force will be reaction. That means when whatever we are applying is if it is action, then whatever reaction, whatever the other force is there, that we call it as reaction. Okay, both are equal and they are in opposite direction. So we will put one minus symbol there, right? So in nature, forces exist in terms of pairs only. Okay, so single isolated force does not exist. That is what Newton's third law explains. Okay, so anything applying force on any object, so there we will get some reaction force. Okay, if whatever force we are exerting or whatever force is exerted over there, if we consider it as action, so there exists some reactional force also in opposite in direction. Clear? Next. So the same example just now when I'm explaining about normal force, if there is some object over there. Okay, so if object is lying over there, so what force is acting downwards, exactly vertically downwards? Gravitational force, or its weight will be acting downwards. Exactly opposite to that, one force will be acting, and or what we call this normal reaction force. Okay, so these two are the action reaction force we can take. Right now, now here this whatever table we are considering there, that is supporting the book, right? So whatever object we have taken, this support it is supporting the object, right? Now, so both the forces which are exerting over there, both the forces, these two forces can be taken as action reaction forces, and other thing is the net force is equal to zero over here. That also should be taken. Okay. Now, some other examples if we take for Newton's third law. Swimming is possible only due to Newton's third law. When the swimmer pushes the water backward, he will be moving forward, right? So the pushing of water backward is action, and the movement of the person towards forward is reaction force, right? So when a gun is fired, the bullet will be moving forward, and due to that, a recoil force acts. Due to that, the gun will move backward. Okay, that is also action reaction forces, right? Next, when we throw a rubber ball downwards, what happens? It will be moving up. Okay, so that is also can be taken in terms of Newton's third law. Here, make sure that one more condition is implied there. when we are speaking about rubber ball, their elasticity also plays key role. Like you can ask one silly doubt, like when we throw a stone onto the same case, why it won't rebound? There, whatever action force is exerted, so and the reaction force is also exerted there, but so there some other extra forces are acting on that. Due to that, it is not rebounding. That should be noted here. Okay. So why, like a rubber ball, why it is not bounded back means rubber ball, no, it is having elastic nature due to that. So this is balanced. Whereas some other case, this is not the balancing because some other extra forces are acting there. Okay. Now, while walking, suppose while walking also, what do we do? So we will be pushing the ground with the help of our foot, right? So there also reaction force is acting, right? So it is difficult to walk on sand or ice. Why? Because there this what do we call action and reaction forces are not balancing there. Some other extra forces are acting. That's the reason we are unable to walk there. Next, uh, when we are hitting a nail into a wall, there also action reaction forces also acts. So these two examples, these three examples, whatever I mentioned, throwing a stone, same like rubber band, and when we are walking on sand, and hitting a nail into the wall. So all these three examples again I will discuss in further topic. There I will be having more clarity. So just I mentioned about Newton's third law and its example, right? So the propulsion of a rocket, when we are launching rocket also works based on the Newton's third law principle. In class 9, you will have one example, balloon rocket. Okay, so that you might have seen in class 9. That also comes under Newton's third law example. Okay, so this is all about Newton's third law, right? So if you have anything to ask, you can.